Good morning, guys. We discuss today physics 2020 February March paper. Okay, right. Uh, let's discuss one by one. The first question. What is the first question? Asked that the diagram show a rectangular metal sheet close to two rules. Okay, this is a metal sheet, rectangular metal sheet, and these are the two rules. Okay, this is vertical rule and this one is horizontal rule. Okay, what is the area of the metal sheet? Very easy. How we get area? How we get area? Yes, it is very easy. In the rectangle, we get area. Area equal length times width. Okay, right. Let's I wrote it down. How how we measure the area? Area, sorry, area equal length times width. Okay, right. What is the length? Yes, length is this one, eh? Right. 10 up to 45. Right, this centimeter. Then we can measure how many centimeters in length. Okay, right. This is 10, the gap is 10. Mm. And 20, 30, yes, this one is 5. Then 35. Then length is 35 centimeter. Okay, we can write then capital A equal length equal 35, 35 centimeter. Then just multiply with width. Okay, let's find the width. Okay, then this is 5 and this one is 25. Yeah, what is the difference? 25 and 5? Yes, difference is 20, 20 centimeter. Right, width is 20 centimeter. Right, then area. Area 35 times 20. Yes, what is the answer? 700 cubic, sorry, square centimeter. Cubic centimeter is volume. Then this one is area. Yes, area of the metal sheet is 700 square centimeter. Then answer is A. Yes, answer is A. Do you want to write down? You can write it now. Right, answer is A. I mark here A. A is the answer. Okay, right, very easy. Then let's move the second one. The graph show how the speed of a car change with the time or over part of the journey. Yes, this one represented by the speed time graph. Okay, right. Then it is represented by the car motion. What is the motion of a car? Then first one, what is uh, represented by this line? Hmm? Angle line. In the speed time graph or velocity time graph, we represent this one, this line as a acceleration. Okay, acceleration. How we represent actually this one is acceleration? Yeah? Gradient, gradient of this graph. How we find the gradient? Yes, very easy. Gradient is equal. Gradient is equal. Yes, y-axis difference over x-axis difference. Yes. What is the y-axis? Y-axis in the speed time graph is speed. Okay, right. Then I wrote it down. Difference of y divided by difference of x. All right. Actually, this is difference of y is speed. Speed over difference of x. This one is type. Okay, right. Then gradient is equal speed over time. Yes, speed over time mean, right? What is that? Speed over time is acceleration. Then in the speed time graph, gradient is equal to the acceleration. Yes. Then how we represent by this one to second one? Second one in the speed time graph, This one is, sorry, this is axis, time axis. This one is speed. Okay. Then this one, the horizontal line. The horizontal line uh, in represent by hmm, constant speed. Constant. This one is constant speed. Okay. Right. In the this first one represent by the acceleration, and second one represent by the constant speed, and third one. Right. This is third one. Huh? Third one represent by the deceleration. Deceleration. This one is acceleration. The first one is represent by the acceleration, and the third one is represent by the deceleration. Okay, right. Then again, fourth one is again represent by the constant speed. Okay, let's talk about this car journey. Yes, first the car is moving, accelerating until get the one speed, and then the car is going constant speed. Then after that, it decelerate and again decelerate and get a speed, and again then that speed the car is moving the constant speed through this journey. Okay, right. Then which section of the graph show acceleration and which section of the graph shows the deceleration? Very easy. Very easy. Then we know the gradient of this graph is given by acceleration or deceleration. Acceleration or deceleration. Yes. Then, yeah, the first one only represent by the acceleration. And then our answer should be A or B, no C or D. Yeah, we can reject. Then, uh, what is the deceleration? Very easy. 2 and 4 are constant speed. Then 3 is already the deceleration. Yeah, right. We get the answer. Answer is B. Second one is the answer. Acceleration is the first one, and the deceleration is the third one. Right. Very easy. Let's move the next one. The answer is B. Right. Third one. A steel ball is dropped from the top floor of the building. Okay, right. Imaging. AR resistor can be ignored. AR resistor can be ignored. Okay, we don't uh, want to AR resistor. Only thing is the weight of the object. Only force is the weight of the object. Okay, right. The steel ball is dropped from the top of the floor. Okay, right. I draw it here. This is the floor of the building. This is the building, our building. Then this is a ball. The ball is dropped from here. When the dropping, the starting velocity, initial velocity is 0 meters per second. Okay, right. Is only weight. Only force is the weight. Okay. See the center, gravitational acceleration, apply the gravitational acceleration. The weight is W equal mg. W equal mg. It's the formula. This is a mass. If you think about this steel ball, mass is simple m. Yes, the g is gravitational acceleration. Then we can get W weight as weight equal mg, mass times gravitational acceleration. Yes. Then what is they ask? Which statement describe the motion of the ball? Very easy. Describe the motion of the ball. Okay. Okay. Right there. Let's read one by one. A. First one. The ball falls with constant acceleration. Hmm. Constant acceleration. Okay. Let's imagine the ball is dropping from the top of the building. See, starting velocity is 0. Then after it's getting speed increase there, the ball's velocity after a few minutes they are increasing velocity. After 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 then it's drop down, it hits the floor. Everything, sorry, with velocity, with one velocity. with higher velocity. uh, if you think about v meters per second. Okay. Then actually what is the acceleration? I told that they told that air resistor can be ignored. Air resistor can be ignored. Then only thing is the weight. Only force is the weight. No, uh, weight is equal mg, mass time gravitational acceleration. That is the acceleration. G, gravitational acceleration. If the gravitational acceleration is vary, no, it is not vary in our situation. In our situation, it's not vary. Okay, then G is constant. G is constant. It has a value. It has a value. We get actually value is 9.81 meters per second square, but we get it as a 10 meters per second square. Second square. Okay, right. Then it is constant value. No, yeah, it is a constant. Then constant acceleration. The G is constant. Then acceleration is constant. First one is the answer, no? The ball falls with the constant acceleration. It is correct. Okay. Let's see others. B. The ball falls with constant speed. No, no, no. See, it start with 0, but it's finished. Hit the floor at V meters per second. It has a velocity. Uh, and the velocity, time to time, the velocity is increasing. Right. Then it is not constant speed. It's wrong. Third one, the ball falls with decelerating speed. Huh? No, decelerating speed. It is wrong. Huh? It is accelerating. Yeah, it is increasing, not decelerating. Oh, accelerating. It is increasing their speed. It is speed. Okay, then it is wrong. The ball falls with increasing acceleration. No, I told G only G is affect to the situation. Then G is constant. Okay, G is constant. No increasing acceleration. This is wrong. Most of the students, uh, they their answer is D. Why? They are not consider about this one. Yeah, resistor can be ignored. Then they are not reading. Actually, they are not reading this one, and they told that increasing acceleration. The ball is falling. Okay, increasing acceleration. Actually, increasing velocity. Increasing speed is the answer. Uh, then anyone is no any answer in increasing speed. Therefore, our answer is A. The ball falls with constant acceleration. This one is constant acceleration is gravitational acceleration. Then final answer is A. Correct statement is A. Okay, A is the answer. Constant acceleration. Okay, right. Fourth one. Diagram 1 shows a piece of flexible material that contain many pocket of air. Okay, right? Many pocket of air. These materials have. Then diagram 2 shows the same piece of flexible material after it has been compressed. After compress. Okay, the same material, same piece, then after compression. Compress, so that is volume decrease. Okay, you see the volume 1 V1 and this one is volume 2. Volume 2 is less than V1. It is small, but it has same piece, and same the only sorry, the important one is the particle inside this material. Okay, particles. If you think about 100 particles, then after the compression, only 100 particles, not 10 decreasing, not increasing. These particles, okay? Same particles and the same materials. If you think this one has 100 particles and V2 after the compression, also it has 100 particles, right? Right. It is very important. It is very important, right? See what happened to the mass and the weight of the flexible material when it is compressed. Mass and weight. Mass is, what is actually mass definition? Mass definition. Mass definition is what? Huh? How many particles? How number of particles in the materials? In the materials. That is the we call as a mass. Number of particles. Right? Weight. Weight is in the previous question we learned that W equal mg. Weight equal mass times gravitational acceleration. Hmm? It is I teach you in the previous question. W equal mg. W can be changed. Sorry. Yeah, W cannot be changed. Hmm? W cannot be changed. Why? Why W cannot be changed? Mass, the same mass, but volume is different. Volume is different. Okay, right. Let's see. Uh, Mass and weight. Okay, what happened to the mass and what happened to the weight? Think about. I give one. I give few minutes. Few seconds. Okay, right. Okay. Hmm? It is very complex. No, it is not complex. I told that mass is not changing and weight is not changing, not affected by the others. Huh? Mass, mass only uh, uh, depend by mass is only depend by the number of particles. I told them the number of particles no change. Therefore, the mass is not change, not increasing, not decreasing. Therefore, answers should be COD, not A, B. A and B. A and B are not the answers. Okay, right? It should be COD. Okay, right. Let's see. Weight. Wait. W equal mg. Hmm? Only, only formula is W equal mg. Weight is equal mass times gravitational acceleration. Mass is not changing. Mass is a constant. Mass is constant. Then gravitational acceleration. Gravitational acceleration is a constant value. It has a value, constant value. Okay, right. This one is constant. This one is also constant. And what happened to the weight? Weight is already constant. These two are constant, not changing. Then weight is no changing. Okay. And therefore, weight is no change. Then the answer is D. Okay, right. Let's move the fifth question. Question number 5. On the moon, the gravitational field strength, same as the gravitational acceleration. G, simple G is 1.6 Newton per kilogram. Okay, right. Moon gravitational field strength is different from compared to the our Earth. Okay, and other planets. Other planets, they are very gravitational acceleration, but in this planet, yeah, the gravitational acceleration is a constant. It is 10 newtons per kilogram. Gravitational field strength. Okay, right. Then on the moon, gravitational field strength is given. Is 1.6 Newton per kilogram. This one, okay, right. An object has a mass of 2 kg. 2 kg. What is the weight of the object on the moon? Very easy. Very easy. We'll already learn the equation. W equal mg. See, same equation. W equal mg. Huh? Then apply. Very easy. Okay. W equal mg. Okay. Field strength is given 1.6. It means G. Simple G is 1.6. And mass is also given. Mass is 2 kg. Then very easy. We want substitute these values only. W equal m is 2 kg, and then it is multiplied with 1.6. Okay, right. Kg to kg cancel and answer given in we gave in Newton. Okay, right. 1.6 multiplied by 2. What is the value? 3.2. This is the answer. Then C is the answer. Very easy. Right. Let's we move the sixth one. Question number 6. Okay. The measuring cylinder contains 40 cubic centimeter of water. Okay. A solid metal ball is dropped into the water and the water level rises to 56 cubic centimeter. 40 to 56. Okay, right. The mass of the ball is 80 gram. 80 gram. Mass is 80. Then water level rise up to 56 from 40 cubic centimeter. Right. What is the density? Okay, density. Huh. Very easy. Let's move the equation of the density. Yeah, density equal mass over volume. Density equal mass over volume. I wrote it only the symbol. Density I given as the symbol D. Density equal mass. It I given as a simple M over volume. Volume I give as the simple V. Then mass over volume. Mass is 80 gram. Then volume. It is not 56. 56 is the final volume. It is not 40. 40 is the initial volume. Then we want to only the metal ball volume, not a water volume. Yeah, metal ball volume. How we get? We can get it as final volume minus initial volume. It is 56 minus 40. What is the value? 56 minus 40. That is 16. 16. Okay, 16. 16 cubic centimeter. Then what is the final answer? 80 gram divided by 16 cubic centimeter. Yes. What is the value? Huh? Value is 5. 5 grams cubic centimeter. No, 5 grams per cubic centimeter. That's the value. Answer. Okay. Answer is 5. Very easy, ne? Very easy. 80 divided by 60 is 16 is 5 grams per cubic centimeter. Okay. Right. Let's move another question. Yeah, number 7. Next. Okay. Then a car travels along a horizontal road at constant speed. 3 horizontal forces act on the car. Okay, what are the 3 forces? Hmm? The diagram show the 2 of these forces. Diagram show only 2 forces. Okay, right. This one, first force from engine. Force from engine is what is the value? 1500 Newton. Okay, right. Then another force is air resistance. Air resistance is 300 Newton. Right. This one is direction of the motion of motion is forward. This one, the car is moving forward. Okay, right. Then what is the size and the direction of the third horizontal force acting on the car? Okay. What is the size and the force? Okay, let's see. The car travels along horizontal road at constant speed. This one is very important. At constant speed. Okay. Then the car is moving constant speed. It means there are no forces. There are no uh, there are no forces acting on this car. No forces. Then we want to add another force to get constant speed. Then otherwise they it has a acceleration. The car has acceleration. Hmm? In this force, forward force is 1500 and the backward force is 300. Then we can get difference. How many? 1200. 1200 difference to forward. Hmm? Then it has a force. It has a force. Uh, in this situation, uh, the difference, force difference is 1200. Then it has a force. Force is equal. What is the equation of force? F equal ma. Then the car has a mass already. Then it has an acceleration. It has an acceleration. It means it is not going constant speed. It has an acceleration. It means it is not going constant speed. Then we want to get constant speed by acceleration equals zero. Acceleration equals zero means there is no any forces applying on this car. The forward force is 1500. Also, it should be backward force is 1500. Then what we want to do? We want to do is add another force to the backward. How? What is the value? 1200 Newton. 1200 Newton. Then after applying this 1200 Newton, there are no any forces. There are no any forces forward or backward. Then the car is moving constant speed. Very easy. Hmm? Yes, 1200 is the answer to backward, not forward. Answer is A. Okay, right. Yes. If you have any question, you can ask. Up to now, right. Then 8 1. A force F is applied to a spinner as shown. Hmm, right. Force. The one force is applying to the spinner like this. Like this. Okay. Right. How? Perpendicular to the spinner. Nah? Perpendicular to the spinner. This line. Okay. Right. Then which action increase the moment of the moment? It's very important topic. Moment. Hmm? Which action? What is the action? Increases the moment of F about the center of the nut. So the nut, the center of the nut is here. Yes, increase the moment. Yes. Let's move to the moment. Moment. What is the definition? Or what is the equation? Hmm? Equation. Moment. I get as a capital E or simple P as the moment. Moment is equal mass times velocity. mv. Moment is mv. Okay. Uh, yeah, moment. This one is momentum. Okay, not a moment. Huh? Moment. This one is momentum. Momentum. We want to find the moment. Yeah, moment is equal force times perpendicular distance. Force times perpendicular distance. FD. In this question, we want to find the moment, not momentum. Hmm? Moment is equal force times perpendicular distance. It is very important. Perpendicular distance. It should be perpendicular. Force times perpendicular distance. Okay, right. Hmm. See, I increase the moment. Which action? Okay, right. A. Apply the force F to the end of the spinner handle. Okay, right. This force is now applying the end of this spinner. What happened? The distance. The very distance. Hmm? The previous distance is this one. I guess as a D1. Now it is increased the distance. D2. Force is same. The same force. Same force. Apply the force F. The same force, no? Same force to the end of the spinner. End of the spinner. We increase the distance. We increase the distance, the same force, constant force. What happened to the moment? Yeah, moment is also increasing. Yes. If we increase the distance, moment is also decrease. Sorry, is if we decrease the distance, moment is decrease. If we increase the distance, moment is increasing. Okay, right. Force end of the spinner handle. Increase, huh? Right. Which action increase the moment? Yes, this one is correct. End of the spinner. Right. See another answer. Apply the force to parallel the spinner handle. Spinner handle parallel. No, it should be perpendicular. The distance should be perpendicular. There is no distance, no any distance to apply the parallel that force. Okay, then it is wrong. Then right. Okay, third one is spray oil on the nut. Spray oil on the nut. Uh, it is not affect increase the moment. It is easy to getting off the nut, but it is not increase the moment. This one is wrong. It's wrong. And the last one, use a short eye spinner. No, short eye spinner. It means the distance is decrease. Distance is decrease. It means the moment is also decrease. We want to get increase the moment. Therefore, this one is not the answer. Mm, Yeah, only one is the answer. A1 is the answer. A is the answer. Increase the moment. Yeah, apply force, same force. End of the spinner. End of. We want to get increase the distance. Right. 8 one is answer is A. You must remember this one, this equation, not to this one, this question, this one is momentum. Momentum is equal mass times velocity. Okay, right. This one is the answer, and this one is the equation. Huh. Right. Next one. 9. A ball is releasing from rest and rolls down a track from the position shows A, B, C, D. There are 4 positions. This one is starting here. The ball is starting here. Right. Then what is the furthest position that is possible for the ball to reach? Furthest position. Huh? Right. The ball. It is here, no? It is starting with here. Okay. Then I draw a horizontal line. It's easy for me to explain this situation. Right. Then I get this one, another horizontal line to parallel to this line. Okay. Right. I get this line, the lower line as a gravitational acceleration. Okay. Not gravitational acceleration. I get what is the energy? Hmm? What energy? Gravitational energy. Gravitational potential energy. GPE. Gravitational potential energy as 0. This line, okay? This line, gravitational potential energy is 0. 0 joule. Right. Then, ah, the starting point, I get CD. No, I get X. Okay, I get X. The starting point. Right. Then, X has gravitational potential energy. Huh? This line is gravitational potential energy 0, but this parallel line, it has a gravitational potential energy. It is not 0. Okay, it has a gravitational potential energy. Then the ball has a gravitational potential energy. The starting point, in the starting point. Okay, right. How about kinetic energy? It is starting with rest. The question is given. The ball is released from rest. Rest. Okay, rest. Rest mean starting velocity is 0. Then therefore the kinetic energy should be 0. 0 joule. Then uh, in the only thing is gravitational potential energy. It has a gravitational potential energy in the start position. All right. Then how we get the kinetic energy equation? You must remember. Did you remember kinetic energy? Ah, kinetic energy. We can get as half times, yes, mass times velocity square. Okay, half time mv square. Okay, right. We can get kinetic energy as half time mv square. Right. This not sorry. This equation is not to help this question. Okay, it is our knowledge. Hmm? Kinetic energy we can get half time mv square. How we get gravitational potential energy? Gravitational potential energy. Uh, Gravitational potential energy equal mass times gravitational acceleration times height. Height difference. Actually, height difference. Okay, difference of the height from the zeroth line. Okay, right. GPE equal mgh. Gravitational potential energy equal mgh, and kinetic energy is equal half time mv square. Okay, right. Then, uh, in the A, this ball is rolling down. Then after, we know it increasing the velocity. Then after this position, in this position, the ball has a velocity. Yes, but gravitational potential energy is zero. Gravitational potential energy is zero. In this line, up to x to a, what happened? What happened to the work? There is a work done. Hmm. Then therefore, what happened to the energy? Energy is transferred. Energy is transferred to one energy to another energy. Yes. What is that energies? Yes. Or also already starting position, the ball has a gravitational potential energy. It has, yeah, sorry, it does not. It does not have kinetic energy. It has only gravitational potential energy. Then that gravitational potential energy x to A is gravitational potential energy is zero. Gravitational potential energy is decreasing up to A. Then kinetic energy in the A position, in the position A, it has a velocity. It mean it has a kinetic energy. It has a kinetic energy. Then kinetic energy, it should be maximum because the gravitational potential, all the gravitational potential energy, it becomes increasing to zero. Yes. Uh, then the kinetic energy is maximum kinetic energy. Yes. Then therefore, the kinetic energy, rest kinetic energy. Then the ball is moving up, up the hill. Okay, right. Then it can be past B, but it cannot pass C. Why? Cannot pass C. The kinetic energy, all the kinetic energy is decrease, huh? Decreasing little bit, little by little. This the ball is climbing up. Then it is increasing height. It means height is increasing, gravitational potential energy again increasing. Okay, then the kinetic energy is decreasing. Okay, it's going the above, above the surface. Yeah, then gravitational potential energy is increasing. In this position, ah, they are in the previous I draw the horizontal line. That's very important. What is that? The gravitational potential is starting position is here. That is the maximum gravitational potential energy. The ball cannot moving away from the this line. Gravitational potential energy is maximum. It cannot get further maximum, uh, by getting uh, another energy. uh. No, it has not um, other energies. Okay, extra energy. It does not have extra energy. Then therefore, it the ball go until this position. I get y. Yeah, until y, it cannot pass y. The ball is cannot pass y position. Yes, because it get the maximum gravitational potential energy. After y, after getting y position, it again the ball is falling down the hill and pass the A. Okay, right. It is not going C position or D position. Okay, right. What is the question? What is the furthest position that is possible to the ball is reach? Ah, yes, furthest from X. Starting from X, it pass A and it pass D, it reach Y. It passes D. Furthest point is should be B. Answer should be B. Furthest point. It reach until Y, but it pass already passed A and B. The furthest point is B. Then the answer is B. Very easy. Okay, very easy. The answer is B. Okay, answer is B. Right. Then we move to the last one, last question. So which row describe an advantage and disadvantage of wind turbine? Wind turbine. Okay, very important. Wind turbine. Let's read one by one. This column is advantage. Next column is disadvantage. A. No fuel needed. Okay. Disadvantage. Harmful gases release. Okay. B. Advantage. Variable supply. Okay. Disadvantage. Fuel needed. Okay. C. Advantage. No harmful gases release. Then disadvantage. Variable supply. Hmm. Right. D. Advantage. Constant supply. Then disadvantage is noisy. Okay. What do you think? What do you think about this one? What is the answer? What should be answer? Yeah? Yes. No fuel needed and supply. Yes. Actually, fuel needed. A little bit fuel is needed to uh, uh, turbine. Turbine. Uh, yeah. In the turbine, we want to some fuel mm, to rotate these turbines. No fuel needed is not advantage actually. Then therefore A is not answer. B variable supply and constant supply. Actually the supply is okay, right? See others fuel needed. Okay, it is not a harm disadvantage. Only little fuel is needed. Noisy, noisy. It's not. Actually, the variable supply is the disadvantage. Variable supply. Okay. Uh, it is. It has a constant supply. It is very important. Okay. Very important. Very important. Actually, very important. Constant supply is a correct one. Correct one is a variable supply is not. Okay. Variable supply and the disadvantage. The variable supply. Yes. It is actually harm disadvantage. It has a constant supply. It is good. Constant supply, we can get electricity constantly. Then variable supply is large disadvantage in here. Noisy, it may be a noise. Not it is a wind turbine generates some kind of noisy, but it is not harmful to the environment. Okay, not harmful environment. Then this is one is not noisy. It may happen, noises happen, but it is not large disadvantage. Large disadvantage is variable supply. Variable supply is a large disadvantage, and the advantage, no harmful gases are released. Actually, the correct one is the harmful gases are no harmful gases are released. To advantage, and the disadvantage is variable supply. Okay. C is the most correct answer. Should be C. Okay. Right. Then uh, up to 1 to 10. How many answers are correct? Yes. It is not difficult. It is not difficult paper. Okay. It is easy. This one is easy paper. Okay. You can get 10 to 10. 10 over 10. 10 over 10 marks in this simple questions. Okay. Right. Then if you have any question, you can ask now. Okay. Thank you so much.